Okay, now we're going to talk about the nth term test for series convergence or divergence. The nth term test, it's one of the first tests that I use. However, you cannot use it to prove convergence. You can only use it to show divergence. Pretty much you have the summation of some function from 1 to infinity. If the limit as n approaches infinity of that function is not equal to 0, then the series will diverge. If we look at these, if it does equal 0, then you'd have to use another test, which we'll talk about later. Here's two examples. In the first one, if I do the limit as n approaches infinity of n divided by 2n plus 1, the easiest way to do infinite limits is by looking at the powers or the degree. They're the same, so I look at my coefficients. 1 over 2. This limit is equal to 1/2. Because that 1/2 is not equal to 0, I'm able to state that this series diverges using the nth term test. As long as this limit equals anything other than 0, you can say that it diverges. And I find it's a pretty quick way to examine them at a glance. Here the power is on top, is larger. If the power on top is larger than the power on bottom, and you're doing an infinite limit, then the limit does not exist, or the limit is said to go to infinity. If the power on top is larger, it goes to infinity. If the power on bottom is larger, it goes to 0. In this first example, the powers were the same. You would look at the coefficients. Now, infinity is not equal to 0, so therefore I'm able to state that this series diverges, again through use of the nth term test. Again, I find the nth term is a pretty quick way of examining them to determine divergence just at a glance. I hope this helps. We're going to look at some other series next. Good luck.